Thank you very much for joining, just to get to know each other. As Tony mentioned, I'm the CTO and co-founder at Epsagon. We're doing observability especially for this. I'm also an AWS serverless hero. In the picture on the left-hand side, you can see me looking for whales in Hawaii. Unfortunately, I couldn't find any. And if you're interested to follow on Twitter, I'm talking about microservices, Kubernetes, serverless, AWS, Lambda, and other good topics. So let's get going. Now, today we'll discuss about monitoring and logging, the more traditional approaches, how we change towards observability, and drill down into distributed tracing, which is the key component today in such environments. So let's start. And first thing that I'd love to start with is what are we monitoring at all? So I think Google's SRE book, and I'll be able to share the link right afterwards, shares this kind of 4 golden signals, this vital signs that everybody here should look when we're monitoring our application. So things like latency, which is important because that's the customer experience that we want to serve. Also traffic, to understand internally how much traffic do we get, is it increasing or decreasing? Errors, which are pretty straightforward, that we want to understand, or zero them down. And saturation, which in most cases I see people ignoring that, but it's super important. Saturation, in other words, tells us how full is our system. So even if looking at all 3 of them, saturation can tell us, hey, we're about to hit a problem in a certain period. So with these 4 golden signals, the way to implement them is usually by deploying an agent, the traditional approach of an agent based on our host. Let's say this is our host. We got some business logic, REST API coming in, and some database that we're communicating with. This host usually collects like CPU, memory, network, disk, and so on. The only inherent problem with this kind of agent is that collects only metrics. It doesn't collect any payload information or any data that tells us what to do. So in other words, it's just the symptoms of a problem that might rise up. When there is a problem, we need to go deeper to the data. We need some more debug data. Hence, we got the logs that helps us to troubleshoot it. In this case, we have another agent-based, at least the agent-based approach that can either dump everything locally in the more traditional applications, or in more modern applications, it ships all of our logs remotely to some centralized location like Elastic, Splunk, or any other solution. The main thing to think with logging data is that it's manual. In other words, if you haven't logged it out in your code, you wouldn't be able to see anything in terms of the logs, because if you're not doing logging, you're not going to see that in your logging solution. Let's have maybe fast forward into the future and talk about what applications are looking today. If we're looking at 2 parameters and characteristics of applications that change from start to an end, so we're seeing that the traditional applications used to have a host-based approach and a monolithic application. Then we broke them down into more of a microservices approach, which introduced some distributed in the essence of the application. But today we're talking about something completely different. We're talking about, in most cases, abstracted hosts. We're leveraging cloud services, managed resources like managed queues, managed databases, managed web servers, and so on. And our application getting in a smaller fractions, and it's getting highly distributed communications with message queues, HTTP calls, gRPC. We have so many ways to look at our system, and this really introduces new challenges, and among them, monitoring and troubleshooting becomes a pain. And if we're drilling down really to understand, for us engineers and DevOps, what changed or what are the new challenges that we're experiencing? So starting first with troubleshooting, being able to look at a customer experience and see how it propagates through different services and correlate all of the relevant logs and understand the journey. This is something that becomes super painful, and troubleshooting today can take us even hours to understand and do root cause analysis. We're also talking about monitoring and in general understanding, is the application working properly? What are the services that we're having? Do we have any bottlenecks? How can we optimize our application? Something that is really hard to do today in such distributed applications. And also in development, because if we're doing this too good, it also can impact our development with slower iterations and slower features to production. So if we're doing it good, it can impact us on development velocity. Now, when we want to approach it in the right way, in the modern way, we need to think about the pillars of observability. Observability tells us or composed with three different pillars: metrics, logging, and tracing. Now, metrics, as we know, tells us like a data set of points that helps us understand what's the trends or what's happening. In other words, it tells us what happened, like a spike in CPU, spike in traffic, or things like that. Usually we got one solution for the metrics. Now we got the logging solution, which once we find out the problem, for example, spike in traffic and slower calls to our database, we need to drill into our logging solution and understand what impacts that, why it happened, what's the root cause. And it's a different solution. There is no any correlation between what we're seeing on one tool and what we're seeing on the other tool. Now, the third part, which usually are not figured out yet in most organizations, are the tracing, which tells us where exactly the problem happened along the chain of services, what's the correlation between the logging and metrics. And in other words, if you're having three different tools for three different pillars of observability, it just kills the productivity, because then, one department uses this tool, the other department uses that tool. It's becoming hard to catch up and understand what's going on in our system. And before drilling down into more of a distributed tracing and the core of this presentation, I want to just suggest some of the best practices out there for logging and monitoring. And I would love to hear if you have any other ones. Please feel free to share them through the chat. I would love to hear them as well. So first, with logging, print out structured logs. Don't print any raw kind of textual information. Print it in a structured way with the metadata, like what's the service name that is currently printing the log? What's the stage? What's the customer that we're handling? Much metadata that will be able to help you pinpoint and troubleshoot in a more efficient way. Also, try as much as possible to automate the process of logging. Every time that you need to manually insert a line of code, it means that somebody might forget or somebody wouldn't include all the information that he needs. If you can make it as automated as possible, that all information will be attached, and in many cases, the logs will be printed out, that's super helpful. And also index the fields that you're using in order to generate charts, metrics, alerts, and anything based on custom metadata that you're shipping out. In terms of monitoring, so I can't say it's out loud enough. Aggregate all your metrics into a unified dashboard. I find myself many times looking at so many dashboards in customers, they have one dashboard for the orchestrator and one dashboard for the infrastructure and one dashboard for the databases. It's just getting hard to follow all of the metrics and correlate them between different tools. Also, define your critical metrics, or in other words, set thresholds. Metrics should be, an alert should be something that if I would tell you, hey, this alert happened at 4 a.m. in the morning, it's something that is business critical and you would hopefully like to get up in 4 a.m. in the morning. If it doesn't worth your time in 4 a.m. in the morning, just set a threshold. You don't want to get alert. You don't want to get what's called alert fatigue, that everybody, like wake up in the morning and see, oh, we had another 100 errors over here and another, errors over there, and everybody ignores them. Last thing, use custom business metrics. This is super helpful when you're shipping out your metrics to monitor your business, because ultimately what your product is doing is about monitoring, is about having a better business. And if you can monitor things like, items in cart or number of processed records or number of customers, minutes watched, things like that can help you enrich your monitoring of your product and your business. Also, and last thing is in monitoring best practices is to monitor also application metrics. I know that for some of you or most of you, it's probably sound very straightforward, but some think that if they are just looking at CPU and memory of a certain host, it's okay, that's their application is running and that will be okay. But it's not enough. You need to look inside your application. And the most straightforward examples are like, what's the average duration of calls that we're making to our endpoints? So we'll know that what's the customer experience is having. The number of calls, for example, to our pipelines like message queues and other services. So we'll know what's the traffic amount that we're shipping through our system. And also number of 400 and 500 errors, which tells us how many errors do we have. And again, these are the most straightforward application metrics. There are tons of them out there, but these are good things to start with. With that saying, and even if we're doing everything with the best practices, it feels like something is still missing. One key question is, how do we correlate between metrics and logs? So as I mentioned, we got problem in, calling the database, like spikes in traffic and slow calls. Now, where in logs do we start to look for that? Now, the second thing is, if we found out the issue about, performance issue or exceptions in the code, how do we correlate the logs and the metrics between different services? Because I don't want to look at each service individually. I want to look at the logs as a sequence of events that led one thing to another until we got the exception or the performance issue. So I want to see them correlated. And that's exactly where distributed tracing comes to help. So let's start with what's distributed tracing at all. In other words, it just tells a story or a workflow or how an event propagates through our system. As you can see on the right-hand side, a client makes a request, it goes through a load balancer to the authentication service and the billing service and another resource. This is the way we want to see what's going on inside of our application. There's the saying, a picture worth 1,000 words. So in this case, a trace worth 1,000 logs, because in this scenario, I don't need to explain to any one of you what's going on inside in here. You already understand it. And if I would show you, 1,000 lines of logs, you wouldn't really understand which services are here and what's actually going on. So that's distributed tracing. In order to do distributed tracing, we need to do two key parts. The first part is to generate the traces. And the second part is to do ingestion and have a client that will show them. Now, when we're doing this, we have multiple possibilities. Some of them are open source, and the open source are listed in here. Open tracing and open telemetry helps us to generate the traces, and we'll dive into them. Jaeger and Zipkin helps us to ingest the traces and do something with them. It's pretty similar in that essence to logs. I mean, you need in one area to generate the right logs that you want, and then you need to ship them somewhere and, build dashboards, index the logs, look for them, like logging in, for example, Node.js, like Winston or Banyan, and on the other end, solution like Elastic and Splunk that helps us to visualize it. By the way, open tracing, open telemetry, and Jaeger are part of the CNCF. And if you're interested to know what's the difference and how things are evolved between open tracing and open telemetry, I would love to elaborate on that. Just let me know if that's something that interests you. So let's start with the first part of traces. We need to generate them. Otherwise, we won't have any traces. Now, there are several steps that we need to do, starting first with instrumentation. Instrumentation, trying to explain it, it's like understanding or automatically hooking to every call that our system makes. Because let's think of it that way. Let's say we have a Postgres database. We don't want to trace for every line of code that we're having in our own application to add another line of code that tells us, okay, now we started a trace of a Postgres call, and now we started a trace of an HTTP external call, an AWS SDK, and any other service out there. We need to do something in an automated way that automatically captures every Postgres call, incoming and outgoing and incoming from our service. So that's exactly instrumentation. It helps us to hook ourselves into the application for request and response. Now, second part is to generate a span. And now I'm talking, the rest of the bold items are things that are part of the open tracing terminology. We need to create a span that span tells us about an operation that started at some time frame and took some duration. So three main parameters that establishes a span. To that span, we need to add some more information that allows us to understand exactly what happened. For example, if I'm making a call to an HTTP endpoint, I want to see things like what's the status code, what was in the headers or in the payload, the path parameters. So I want some more context added to this span, so it will tell me more details about just, this was the event. Ultimately, we need to take care for injection and extraction of IDs as we move between services. When we're making this HTTP call, this, the endpoint can be some other service that we own. So we need, in this case, to inject some unique ID, some magic number that will tell, hey, everybody, if somebody is listening out there, I'm part of a transaction or a trace with this sequence ID. If you're getting this, continue the same sequence ID. Otherwise, just start a new span or start a new trace. So we need to do that in both ways. We need to inject it when we're going out of our service, and we need to extract it back when we're getting back to our service. Just as an example from Open Tracing, this is a simple handling for incoming requests in any kind of a web framework like Django, Flask, Tornado, and so on. As you can see, it's not meant to be readable. You just understand that it's a lot of code that you need to take care for once you're doing it. And this is just a small fraction that needs to be done to enrich it with some like HTTP URL, the remote IP, caller name, things like that, that will help you understand what happened in your code. Once we generated the traces, we need to ingest them and have a client that will show us that. So things to consider when we're thinking about what would be the best client, we need to think about what's our scale. Are we streaming millions of traces per day? Are we streaming billions of traces per day? This is scale that we'll need to handle. Also, we need to index the context and the tags that we're sending for easy search. For example, show me all calls that the status code was 400 or 500. Ultimately, we want to be able to visualize traces as it will show us this simple graph as we've seen before, like either in a graph or a timeline that really tells us what happened from end to end. And we want to set up alerts when something goes wrong, and we want to do a lot of things. You know, this is just the tip of the ice with what we want to do with traces as the client can provide us. Out of the box, Jaeger provides us this timeline view, which again helps us understand much better instead of logging, and we can see exactly how the request is propagated through different services. So that's great, but it do lack most of the functionality that I've mentioned before. Some other tips that are really good when we're doing tracing. So first is about tagging traces. Adding custom tags, and I'm not talking about the plain simple context, I'm talking about enriching it with some more context that will allow us to do some interesting things. Things like identifiers. For example, let's say a user comes to you and say, hey, I had a problem with your website or your service, and you can just type user ID equals that user ID, and you'll see all of the traces, all of the calls, all of the events that related to this user. So that's super helpful. And again, any kind of identifier that is unique to the talk, things like user ID, customer ID, device ID, and so on. Second comes the flow control. Things that will help us understand what's the logic that we're doing inside our code. Like, you know, event type, like in this way, I'm handling an event type of a purchase item, and in this one, I'm handling an event of replace an item, or business logics. This will be able to tell you what's happening inside your application. So you'll be able to generate and aggregate data. For example, how many times is there a purchase new item versus replacing an existing item happening in my system? Or what's the performance benchmark for X versus Y? And last thing, this is a good kind of ground to set up business metrics, like items in cart, minutes watched, anything that is specifically for your business that you're looking to monitor and understand over time, and understand them even in a specific scenario that you're pinpointing an issue. This is super helpful as a business to grow and gain more observability. Last thing that is tracing can act as a glue. If you're doing the right tracing, trace can tell you where it's running, so connect to the environment and vice versa. For example, if you're having a problem with a specific pod or a specific task or a specific function, you can just say, show me all error traces which happened in this environment. Or when you're looking at a trace of a problem, you can say, show me the environment metric, like, I know, CPU metrics of that database when we're in the trace itself. Also, trace can correlate to logs. For example, fetch the logs of that specific trace when I'm looking at it. I don't want to search for logs because that's a pain, that's hard. In trace, I can get into the exact event that I'm looking for and then fetch the relevant logs from there. Just, you know, recapping some of the best practices for observability and what's a good kind of approach to do so. So first, we want to look at the solution that is fully automated with zero setup, no maintenance, no training. As we saw, open tracing and Jaeger requires heavy lifting, and some of the existing solution would require from you to set up dashboards, configure alerts, build, you know, custom metrics and so on. But within Epsagon, everything comes out of the box. By the way, the screenshot taken from Epsagon, and as you can see, you're seeing trace going from Kafka to S3 and a Lambda function and ECS, like a mixture of of an application. It should support any of your environments, of your modern environments, Kubernetes, cloud, AWS, Azure, serverless, containerized microservices, all comes out of the box. It should connect every request in any transaction through message queues like, Kafka or RabbitMQ or Redis or SNS, SQS, and any other service out there, or HTTP calls or gRPC, or any kind of method that allows you to move between one service to another. Also, we need something that will help us search and analyze the data. For example, with the things that we saw before, like show me everything that relates to this user ID, or show me how many times a user purchased an item on my website. And ultimately, something that will help us pinpoint and troubleshoot issues quickly. So search for an user ID and understand what was his journey and where it failed, and how do we fix it in the most fast and efficient way. So just as a summary before wrapping up, modern applications, as we understand, requires more than just monitoring or more than just logging. It's a kind of a different approach that needs observability, or something that is more complete than just these two. Distributed tracing also becomes a very crucial component in such environments, because otherwise you just can't really understand the nature of them and understand what's going on. And I think as a good tip, if you're moving to a modern application, usually you want to focus on what your business delivers, rather than building infrastructure and building your own internal tools. So stop implementing your own solutions unless needed. If you're looking for an observability solution, pick something off the shelf, because in most cases it will cost less than the total cost ownership that you'll have maintaining and implementing a solution in-house. Just for all of you, and right now you can sign up for Epsagon for a free trial. You'll get extra benefits and an extra 3 month for your account. We support out of the box any kind of Kubernetes workloads, Lambda functions, AppSync, EKS, Fargate, ECS, Azure workloads, and any other containerized environments. So feel free to get started. And a special offer for viewers now only: if you get to epsagon.com/DeveloperWeek, you're kind of going to get a cool, very cool drone, or cloud kind of drone that you can see below here. So go ahead, sign through that, and you'll be able to win your own drone shipped to you. Thank you very much. As I mentioned, this is my email, so feel free to ping me, or also on Twitter if you're interested to hear more and learn more about any news or anything around microservices, Kubernetes, serverless, and other topics. Thank you very much. If you have any questions, please feel free to share them now. I would love to answer them. Yeah, I see, Sahil, that you wrote about Flask. It might be seen as a niche. I know that the top popular services for web framework in Python are, I would say, first place is Django. It's probably the most common framework, but that's a kind of a heavy framework that you'll need to use. Flask is winning in favor for having a simple framework, more simplicity, more kind of approachable. So I wouldn't call it as a niche. It's probably like the second top framework, web framework in Python. So that should be good. Theodore, I see your reference about PII in tracing. I know that it might be an issue to stream this data. At Epsagon, we solve it out, first of all, by being compliant with GDPR, HIPAA, SOC 2, and ISO, and Privacy Shield. But it's up to you whether you want to send this information. It's super helpful, and it's helped you to understand it. And in most cases, most of the data is not sensitive. Like a customer ID is usually something internal in your system that doesn't really say anything about the identifiable information of the user. So that can be really helpful. And again, it's really up to your team and up to your organization whether they can do that. Regarding the presentation, so the recording will be available in a few weeks, just as Tony mentioned. I'm reading your Alex May question. What are your thoughts for logging, tracing, observability for single-threaded environments like Node.js? How do you get access to context and HTTP requests? That's actually a good kind of question, and I can drill down with you to that. But with Node, there is the concept of async hooks. It's a very internal library inside Node project. You can read about it, and I can share the links. Async hooks let you understand context as it propagates through different threads or different, within the thread, different promises, especially on async IO kind of operations. And Epsagon already leveraged this to understand when you're making an HTTP call from a different kind of a promise or a different kind of event in the event loop, how to correlate between them together. So ultimately in the trace, you'll see them composed together. Al-Mata, for your question, if we support Azure, yes, we support Azure. We support any workload today that is running on AKS or the serverless functions. Currently with Node and Python. If you have any other language, so feel free to ping me over the email or share your details with me. I would love to approach you on that, but that's definitely supported. That's a great question, Elisa. So how Epsagon helps the financial industry? It helps in general everything related for engineering teams. So even on financial industry where you develop applications or services to your customers, somebody needs to monitor them, somebody needs to make sure the SLAs are being met, that the business is running properly. So in that kind of scenario, Epsagon helps you to gain confidence that everything is running properly and get alerted when something doesn't work. And this is super crucial. Now, specifically for the financial industry, Epsagon can also leverage the tracing to understand the business internally. Using the custom tags that I've mentioned, it can really help you understand, things like how many customers are you serving at a certain point, or what errors are your customers experiencing, or what's the operation that they're doing inside of their services. So it's really helpful for any kind of a vector, but for financial services, it can really help to drive business forward and help engineering and DevOps teams really to push and so on. Theodore, I see your question. I see that you're saying open anonymized data sets. And yeah, again, I think that IDs are not sensitive. Like a UUID of a customer inside your application, usually it's not considered as a PII because that's something internal for you. I do agree that emails or things like that should be scrubbed. And again, Epsagon gives you the ability to scrub any information that you're not interested in going out, or you can do that. It's pretty similar to logs in that essence. Again, the logging information that you're going to ship out is going to ship out, but you can decide what's going out and what's not. Gomothi, can you elaborate on what do you mean for native apps? Are you talking about React native apps or native apps in other programming language? In general, Epsagon supports today Node, Python, Java, .NET, and Go. So any application built on this programming language and any of their frameworks is supported in terms of tracing. We got just a few seconds left out there. So if there is no question, I'm still going to be here. But thank you very much, everyone, for joining. That's delightful. I would love to catch up with you, everyone, afterwards. So feel free to, to direct message me in any platform over here or Twitter or email. And again, thank you very much for joining. I hope you all have a rest Developer Week experience, which is great for all of you. Thank you, everyone.